And welcome to the last part of section 5.1. We have two problems to go. Look at this system of equations right here. 3 over x plus 3 over y equals da-da-da, and 4x minus 2y equals a fraction. So you can tell just by looking at this that this is going to be hard to do because we have x and y in the denominator and a whole bunch of fractions. So there's a trick to doing this, and the trick is to let p equal 1. Make up a variable, whatever letter you want, in this case p, and let that equal 1 over x, and let some other variable equal 1 over y. Because when we do that substitution, it'll make this a lot easier to solve, and then we can just work backwards to get p and q. So here's how you do this. Let p equal 1 over x and q equal 1 over y. That transforms this into 3p plus 3q equals 27 over 20. Do you see that? So it's 3p because p is 1 over x and q is 1 over y, so it's just 3p plus 3q equals that. And you can see that this is a lot easier to solve now. Do the same on the bottom. The bottom would be 4p minus 2q equals 3 over 10. So that's what the two equations become, and now you see that they're a lot easier to solve. So from here, we can see that elimination is probably going to be the best method to use. What I'm going to do first, though, is I'm going to multiply to get rid of these two fractions, because these fractions are kind of hard to deal with. So let's multiply the top equation by 20 and the bottom equation by 10, just to get rid of the fractions. So that's going to be 60p. The numbers get big, but that's okay. Plus 60q, and the 20 cancels the 20, so we just get 27. So that's nice, no more fractions. And on the bottom equation, multiply everything by 10, so that's 40p minus 20q equals 10 cancels with 10, and we just get 3. So that's a lot nicer. Now we don't have any fractions at all. So I can see elimination is the best thing to do. Q would be the easiest to eliminate. And so let's multiply the bottom equation by 3, because then we would have positive 60q and then negative 60q on the bottom. So I'm just going to rewrite the top equation over here, which is 60p plus 60q equals 27. And on the bottom, I have 4. Oh, we're going to multiply the bottom equation by 3. So let's do that. So that's going to be 120p minus 60q equals 9. Okay? So all I did there to go from here to here was I multiplied the bottom equation by 3. So that becomes 120p minus 60q equals 9. Don't forget to multiply that last 3. That's a common mistake. The 60q's cancel, which is what we wanted. So we get 180p equals 27 plus 9, which is 36. So divide both sides by 180, and we get p is equal to 36 divided by 180. And I believe, does 36 go into 180? It does. So 36 goes into 36 one time, and 36 goes into 180 5 times. So p equals 1 over 5. And okay, so that's useful. Now let's figure out what q is. So unfortunately, it looks like it's going to be a fraction potentially. Or maybe not. Let's plug it into the top equation. Okay, so that's going to be 60 times p is 1 over 5. And again, I just reduced it. That's how I got 1 over 5 from this. So 60 times 1 over 5 plus 60q equals 27. This is nice. 60 times 5 is a fifth, is 12. Okay. Subtract 12 on both sides. And divide by 60. So q equals 15 over 60, and so that reduces to 1/4. Okay, so we've got p equals a fifth, and q equals a fourth. But that's not what we want. Remember, what we want are x and y. So we found p and q going through a bunch of trouble. So now how do we find x and y? Well, remember, here's how. This is what we let p and q be. This was the bridge. So they're just the reciprocals. So p is the reciprocal of x, q is the reciprocal of y. So basically, you just need to flip the fraction. X is the reciprocal of p, so x equals 5 over 1. So x just equals 5. Do you see that? Because it's just a reciprocal. Likewise, y is the reciprocal of q, so y equals 4 over 1, so y equals 4. It would have been a lot harder to try to solve this with x and y staying in the denominator. So that's why we did p and q, to work it out with p and q, which then is just one step away to get x and y. So the answer to this would be 5, 4. All right, hopefully that made sense. Always remember that your final answer would be in terms of your original variables, x and y. Let's do the last one. The sum of two numbers is 52 and their difference is 4. Luckily, this is way easier than some of the ones in this section. The sum of two numbers is 52, so I'm just going to call that x plus y is 52. The difference is 4. X minus y is 4. Remember that difference means subtraction. You can see right away that this is set up for elimination. So 2x equals 56. Divide by 2, divide by 2. X equals 28. Okay. So we have x equals 28, so let's just substitute. Let's do the top equation. 28 plus y equals 52. Minus 28 minus 28. Y equals 52 minus 28, which equals 24. So there's two numbers that add up to 52. And when you subtract them, you get 4. And you can see that that works out just by looking at it. Congratulations, you made it through section 5.1. This is one of the hardest sections in college algebra, probably up there with 3.6. This one and 3.6 are probably the two hardest. So we made it. I will see you in section 5.2, where we're going to learn about something really cool called a matrix, which we can use to solve these equations way easier. So I will see you in section 5.2. If you like this video, please like and subscribe. Any questions, please make sure you leave them in the comments. Thanks so much. See you in 5.2.